guys, this is test 31, game 1. This is the lockers game with the boys and girls. It's an ordering game because we're putting the lockers in order from 1 through 5, and we're assigning the boys and girls to the lockers. Now, I've laid out a lot of stuff here, but don't worry, I'm going to explain all of that. We've got the boys FJMP, we've got the girls NRT. They tell us in the first rule that each locker is assigned to 1 or 2 people, so we could have potentially up to 2 people per locker, so that's why we have the 2 rows of 5 slots each. Of course, some of these slots will be empty. When they say each child is assigned to exactly 1 locker, that's simply telling us that all of the children have to be used. It's something of a loophole closer. The second rule tells us each shared locker will have a girl and a boy, meaning that we can't ever have 2 boys in the same locker, and we can't ever have 2 girls in the same locker. So for that reason, I've separated out the boys and the girls. You see here, we've got FJMP on the boys level and NRT, the girls, on the second level. So any locker that has 2 people on it will, by necessity, by virtue of the layout here, have a boy on the top and a girl on the bottom. Now, I've also included some X's here, although there were no X's in the discussion on the page, the initial paragraph. That's because if we have 5 lockers and only 4 boys, one of the lockers will have no boy at all, and so I want to be able to designate that with an X. For the girls level, because we only have 3 girls, exactly 2 of the lockers will have no girls at all, and as such will simply be XX for the girls. So that's the layout here. I've got Juan sharing a locker, therefore Juan has to be with somebody else, although we don't know who, so I've left an open space there below him on the left here. Rachel does not share, so Rachel is with the only boy level X, the X that I have right over here, meaning that the other girls will all have to share with a boy. Now, I've also listed N and T cannot touch, so I put TN and T with slashes through them. F is on 3, meaning that Rachel cannot be on 3 because Rachel is with the boy X, not with an actual boy. So if we have Rachel with the only boy X, then we know that all of the other girls will have to share with some boy, meaning that at least one of N or T will have to share with J. J cannot be with an X, of course, as we've already discussed. J has to be with an actual person, so I'm going to put down J is with N/T, and the other one of the girls, T/N, will have to be with one of the boys. So we've got J is with N or T. I'll just draw it a little bit bigger so you could see it. J is with N or T, and then the other one of N or T, whichever one does not appear with J, will have to go with one of the other boys, meaning that she will go with F, M, or P, just so you can see exactly what I mean here. Basically, all of J, N, and T have to share with somebody. None of them can be alone with an X. We know that J has to share a locker because the rule tells us directly. We learn that the other one of T or N has to share with the other one of the boys, simply by virtue of the rules themselves, due to the number of things that we're dealing with here. So this is our initial setup for the game. So to question number 1, general could be true question regarding a complete and accurate list of people who always have to share. So as I was just discussing, we know J always shares with one of N or T, and then the other one of N or T will always share with one of F, M, or P because the boy X is occupied by R. So the other girls all have to share with an actual boy. So J, N, and T are the 3 who always have to share, so E is our answer for number 1. Next, question number 2. If T is on 3 and M alone is on 1, so I'm putting T on 3 right here, we know that M is alone on 1, meaning that M is with one of the girl X's. We know that T and N can never touch, so N cannot go on either 2 or 4. It will have to go on 5 with J, because J always shares with one of N or T. J can't share with T because F's got it, therefore J's got to be with N on 5. So there is some ambiguity remaining. We have, of course, RX, we have P going with the other girl X. We don't have to actually place that stuff down, though. We have enough to solve the question because they're asking about must. What must be the case? Must J be on 4? No, it has to be on 5, so A is gone, and B is our answer to number 2. I will run through the rest, though. Must P go on 2? No, P could go on 4 instead, so C's gone. Must R go on 2? No, it could go on 4. Must R go on 5? No, in fact, it cannot go on 5 because J and N are there, leaving B is our answer to number 2 if you didn't get it before. Next, number 3. If the 4 boys are on consecutively numbered lockers and J is on 5. So, of course, if J is on 5, then we're going to have no boy at all on X, and then we'll either have M on 2 and P on 4, or we'll have P on 2 and M on 4. Now, of course, J is always with one of N or T, so we can lock that down right there. We know we're not going to have any person on 4 because T and N cannot touch, and Rachel can't be with an actual boy. Rachel's going to be on number 1. So we know that the remaining spaces here, one of them is going to be T or N. The other one will be X. We don't know exactly which one goes which way. It doesn't matter, though. They're asking regarding what cannot be a shared locker ever. So, of course, locker number 1 has an X on it, and locker number 4 also has an X on it. So 1 and 4, choice D is our answer for number 3. Next, number 4. Once Rachel has been assigned, how many lockers could be a locker that Juan goes to? So Rachel, of course, is always with nobody. And we also know, of course, that F is never with J because, of course, they're both boys. So Juan can never go with F, and Juan can never go with Rachel. So we've got 5 minus 1 for the Rachel locker minus another 1 for the F locker equals 3. So there are 3 lockers remaining after we account for the Rachel locker and the F locker, which, of course, are not going to be the same locker. They do not overlap. So for that reason, 3, choice C, is our answer for number 4. Next, number 5, if the first 3 lockers go to girls, meaning that we're going to have R on 2 to break apart the resulting N and T on 1 and 3, because we know that N and T can never touch according to this rule right here. So since one of the girls is already used up on locker number 3, the T/N, the other has to go on 1 with N/T. Of course, Rachel is with nobody. Then we have M and P interchangeable on 4 and 5. We either have M on 4, P on 5, or P on 4, M on 5. And then we don't have any girl at all on either 4 or 5. So they're asking us what must be true. Of course, we already know J on 1 is a must. It's our answer for number 5. I'll look at the rest, though. N on 3 is not a must because N and T are interchangeable on 1 and 3, so B's gone. T on 1, same thing. N and T are interchangeable on 1 and 3. J with T could happen, but J could also be with N, so D's gone. And then P with T is impossible, given that T's on either 1 or 3, and P's on 4 or 5, leaving A for number 5. Next, number 6. I'm going to leave number 5's work here simply because I'm going to want to refer to it in a little bit. Anyway, number 6 says if lockers 1 and 2 are each assigned to one boy and are not shared lockers. So, of course, if they're not shared, that means no girl is on them. So I'm putting X's for the girl slots on 1 and 2. We then have to have the 3 girls, N, R, T, on 3, 4, and 5. Because N and T cannot touch, R is going to be on 4. We'll have N on 3, T on 5, or T on 3. And then we'll have, of course, N on 5. J has to share with either N or T. It can't share with whatever's on 3, so it has to share with whatever's on 5. Of course, Rachel's always with nobody. And then we have M and P interchangeable on 1 and 2 with either M on 1, P on 2, or P on 1 and M on 2. So they're asking us what must locker 4 be assigned to. Of course, it is Rachel, and C is our answer for number 6. Now, what I want to show you is that the diagrams for 5 and 6 are actually mirror images of each other. The lockers are ordered 1 through 5, but they're not in any kind of chronological or ranking sequence. So for that reason, we could take each one and essentially flip it around, changing 1 to 5 and 5 to 1, 2 to 4, and 4 to 2, leaving 3 the same. So if you look at this here, 3 is identical in both layouts, right? Both of them have F and on the boy level, and then N and T on the girl, N or T on the girl level. We have X, X on 4, 5, X, X on 1, 2 in the other diagram. We have J on 5 on the bottom. We have J on 1 on the top. We have R on and X on 2. We have R and X on 4. So these diagrams are mirror images of each other. If you'd happen to spot that, of course, you would not have needed to draw a new diagram for number 6. I'm not saying that you would have seen that, of course. It's very difficult to spot. But if you recognize this sort of thing in a game where it is not chronological or not ranking, but you have things laid out in a sequence like this, you might be able to save yourself some time over the course of the game, because any scenario that you've drawn is automatically worth two scenarios, two valid scenarios, because you can easily flip any of them around. So what's true of it one way is also true of it the other way. Regardless, don't worry about this too much. It's like a higher level thing. If you see it, great. If not, don't worry about it. Anyway, C is our answer for number 6.